congruent to each other. They are exactly the same shape. They're exactly the same size. That's how you know they're congruent. So if the three sides are marked, you can use side congruence theorem, or SSS, to say that they're congruent. To use this one, you have to know the three congruent sides. That one's easy peasy. Because the sides are congruent, there's no angles involved, so it's SSS. The next one that you can use is side, angle, side. If you look at your two pictures that you have for this one, you have a side, you have an angle, and you have a side. Notice where the angle is located. The angle is between the two sides. You have two connecting sides. They're connecting at R. They're connecting at U. The angle is between the two congruent sides. So the key for this one is that you have two congruent sides. The angle, A is in the middle. You need one angle in the middle. The next one is for right triangles only. So if you look at your pictures, hypotenuse leg is the least theorem, or the least used theorem for congruency triangles. This is only for right triangles. Only for right triangles. You need to have that 90-degree symbol there. And the only things that you need to use, this is the only one that is 2 letters. If you look, it says hypotenuse leg congruence, HL. You need to know the hypotenuse is congruent, which somebody was like, I've never heard that word in my life. Does anybody know where the hypotenuse is talked about, or like where you heard it from before? What? The what? The big side, but like what thing have you learned about before? Yes. What is that formula called? Yes, the Pythagorean theorem. So the Pythagorean theorem talks about hypotenuses. So I'm going to just call this hypotenuse for short, just in case you don't know. It's the longest side. So if you know the hypotenuse is congruent and you know one of the legs are congruent, you can use HL as long as the 90-degree symbol is there. Then you can say hypotenuse leg for congruency, because we're going to use these for proofs. So this is where this really comes into play, as proofs. These are the two that are very similar to each other that you are going to mess up and switch up. Notice that they even made the pictures look identical. So they're in the same exact placement. They didn't turn the triangles literally at all. The only thing that's different between angle, side, angle and angle, angle, side is where the congruent side is at. So if you look, you have an angle, you have a side, and you have an angle. This side is in the middle. That's why S is in the middle. So you need two congruent angles and one side in the middle. Compared to the next one, the theorem is angle, angle, side. Notice the S is in the back. If you look at your picture, the side that was congruent here, this was between the two angles. You have angle, side, angle. You're just kind of going in order. You can go left to right, right to left, doesn't matter. Angle, side, angle, angle, side, angle. This one specifically, that congruent side is not between the angles. You have an angle, and you have an angle, and you have a side. It is not between the two angles. So you still need two congruent angles and one side not in the middle. Equal sign, that's a congruent sign. Hopefully we know that by now. This is not an equal sign, a congruent sign. It's basically the same thing as an equal sign. What's up? Is the pass back there? I think somebody is out. When he gets back, you can go. So those are the 5 theorems that you can use. Now we're going to talk about shortcuts that you cannot use. So these are not allowed. So these are no-nos. Because you're going to, all of these sound very, very similar to each other. You're like angle, side, angle, side, side, like blah, 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 side, angle, side. They all sound very similar. And you're like, there's S's, there's A's, and there's a random hypotenuse leg. In this case, these are the rules that you cannot use. You cannot use AAA. AAA is a car company. that comes and saves you whenever you're broke down. You call AAA, they come get you. Okay. AAA is not used. It's not allowed to be used because you could have a triangle that's very, very teeny tiny that has the same angle measures as a really big triangle because they don't talk about the side lengths literally at all. So you can't use AAA. What's up? It's not animal control. It's like, I don't know what it stands for. It's a towing company. It's like if you lock your keys in your car, which I've done before, and I called AAA, they come get my keys out of my car. If you run out of gas, they will come bring you gas. If you break down because your engine blew, they'll come tow your car to wherever it needs to go. You have to pay for it, but it's called AAA. The last, huh? No, I'm not, but I'm saying like they're a great company if you can afford them. They cost money. Boop, boop, boop. I don't have them anymore. I just called my husband. I'm like, help. Help. Somebody's out. The last one that you cannot use, so you cannot use angle, 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 and you cannot use the donkey. So we cannot cuss in math class forwards or backwards. So you cannot use ass as a theorem, or you can't use it backwards either. So you cannot say ass forwards, you cannot say it backwards. So if you're like, yes, this is side angle, and you're like, if I flip that, that's ASS, I cannot use that for math class. Because like if the, where's my thing? Like if you have an angle, which I don't know, should I just draw like a random picture? Let's draw a triangle. If you have an angle and a side that are congruent, this side could technically expand, keeping these side lengths the same. Like, oh God, how do I draw this? Like this angle would be the same. I don't know how to like draw it. I'll show you. Let me pass out the classwork really quick and then I'll come over there. Can I go up? Yeah. To the top? Like how far? All the way? Yeah. Okay. So we're gonna do the first two together. Take one top down. Are you saying your condolences or something? Yeah, it's hard. Okay. If you look at the first problem, this involves what we were doing on Monday and on Tuesday. It is key how you write the triangle. So you have to tell me what theorem you're using. You have to tell me how you would write the triangle. So if I say triangle ABC is definitely congruent, none of these have the shortcuts. None of these are trying to trick you today. They are all going to work. If I say triangle ABC is congruent to the other triangle, if I look at angle A, I have to find its friend on the other triangle. So what would angle A match with on the other triangle? R. If I look at B, B is between the no leg side and the one tick side. So what would B match with on the other triangle? W. C has one arc mark, so C is obviously going to match with what? I. Now we have to pick the theorem. It says by blank. Is this side, side, side? Is it angle, side, angle? Is it, I don't know, hypotenuse, leg? So take a second, look at the triangle, pick one triangle to look at. If I look at the first triangle, A, B, C, what theorem could I use if I know two sides are congruent and I have one angle that's congruent?
SAS.
SAS. The angle is in the middle between the sides, so it's side, angle, side. Let's look at number 2. Number 2, try to match A with its friend, try to match B with its friend, and C with its friend. How the first one's written determines how you must write the second one.
Bro, Bill is bullying me right now, bro. What the freak?
Give me some.
My bad.
What would A match with on the other triangle? E. A matches with E. If I look at B, B is in the middle. What would B go with? S. And then the last one. And then by what theorem could you say they're congruent? Side, angle, angle, or angle, angle, side. If you write it backwards and if you say side, angle, angle, I'm fine with that. But you have two angles and you have a side. The side is not between them, so it is angle, angle, side. Let's jump down to number 10 really quick. Number 10 looks a little funky because if it was in the middle, it would be between the two congruent angles. You're not going to see how there's a little blank. We have a little empty spot. We have a little empty spot. So you can't go that direction. You would go to the right instead because it's directly next to it and then it's directly next to it. So you don't really want gaps when you're trying to follow to create a theorem. Okay, let's jump down to number 10. Number 10, the triangle just looks a little funky because they put an angle marker, like a congruency marker inside the angle, which they can do technically. Most of the time you won't see it like this. So this little extra line here, it's just saying this is congruent to this angle. So if I look at A on the first triangle, A's got nothing going on. So what letter would match with A? K. If I look at B, B has two arc marks. T has two arc marks. C has one arc mark with a tick. And G has one arc mark with a tick. And then what theorem would you use for this? Angle, angle, side. Or side, angle, angle, side. It's not a big deal. Because this congruent side is not between the angles. If you have two angles, it's either the side has to go in the middle or it has to go in the beginning or the end. So in this case, I have angle, there's an angle next to it, side is in the back, or you could say side, angle, angle, but there is not a congruent side between the angles. Do you want to do one more together or no?
So question. What is the difference between AAS and ASA?
That's where the side is in the middle. So in this triangle, the side, the congruent side is not the tick mark that I'm looking for, is not between the angles. This is angle, angle, side. Okay. Okay, let's do 7. 7's been tripping people up. So take a second. Look at number 7. Number 7's a little trippy just because it's got no angle marker, so you really got to look at the sides. So A is between the 1 tick and the 3 ticks. So what would A match with? I. I is between 3 ticks and 1 tick. B is between 2 and 3 ticks.
IHL.
No.
ILH. Yes, it is.
No. LH.
Sounds good.
He's not actually trying, he's just talking.
I am trying.
Not really.
Bro, I'm pretty interesting to see something. Say what?